Okay, tonight's homework is on solving proportions and percent change. You will get official notes on percent change, so if you'd like to skip that part of the homework, then feel free to do so. But the proportions part is a review from 6th grade, so we can definitely knock out some of those right now. On side B, I am going to go over these 1, 2, 3 examples, numbers 11, 21, and 26. So the first 12 problems are about finding out whether or not this is a true proportion. A proportion is two or more equivalent ratios, and it has an equal sign with a question mark on top to see if these two are equivalent to one another. In class, I showed you through cross multiplication to prove whether or not they're true. That means if I multiply 9 by 21 and 8 by 24, if I get the same product, then these two indeed would be proportional. So over here to the side or wherever you're showing your work, you can do 21 times 9 and then 24 times 8. So 9 times 1 is 9, 9 times 2 is 18. And then 8 times 4 is 32. And then 8 times 2 is 16, plus 3 is 19. Now, I could have looked at the digit in the ones place and already been able to tell that these two are not equivalent. So for this answer, I'm going to put no or not proportional. Okay. Then for the next part of the assignment, it had two ratios and then it had a missing value. So we're doing the same concept, except I'm not going to cross multiply both of them. I'm just going to cross multiply by the two numbers that are diagonal from each other. Now, if you want to get technical, you're cross multiplying both like this, but then this would be 19x equals 20 times 57. And in order to solve this equation, which we've solved equation before, to get rid of the 19, we would divide both sides by 19. Divide by 19, divide by 19. So that's the cross multiply and divide method. I really just use those two numbers and the third number, those three numbers, and leave the variable out to solve for later. Cross multiply and divide. So 20 times 57, then divided by 19. So I'm going to work that out. 57 times 20, 0, 2 times 7 is 14, 2 times 5 is 10, plus 1, that's 11. So this is 1,140. You could do 1140 over 19. Then you would divide. This is a long division problem. So I need to take, so I need to take my 1140 and put it inside my division problem, and then my 19 and put it outside my division problem. So what that is going to look like is, whoops, let me get some other paper. $11.40 divided by 19. Now we can do our multiples of the divisor, which is 19. And in class, I did a couple of examples in some people's classes with a problem that has a number, or a problem that's dividing by 19. So I like to give you multiples by adding 20 and then taking one away. What that looks like is multiples of 19 are 19. And then 19 times 2 is I add 20 to 19 and I take one away. So 19 plus 20 is 39, but then I take one away, which is 38. 38 plus 20 is 58, and then I take one away, that's 57. 57 plus 20 is 77, and then I take one away and I'm at 76. So I do my first 9 multiples of 19 because I can only put one digit on top of each place. Here are my multiples. Now that I have my multiples, I can divide. 19 will not go into 11. So I put placeholders there. That should be an X. Then 19 into 114. I count 1, 2, 3, 4, 5, 6. 114. 114 minus 114 is 0. Bring down the 0. I have to go into my last place for my division problem. The answer is not 6. I need to go to this last place, at least up until this invisible decimal. So 19 does not go into 0, so I put a 0 up top, then bring down my 0, and then I'm left with no remainder. So that answer is 60. Now another way I could have done this was I had 20 times 57 divided by 19. 57 is a multiple of 19. I very well could have simplified here and done 57 divided by 19. Cross that out and make it a 3. This 3 is left, so I can multiply 3 by 20 and I will get 60. All of that was mental division over here, but you have to identify multiples of 19 and you have to be able to know what 19 will go into and have a whole number left over. Obviously, it wouldn't have been 20 because I would have had a remainder. So then my X is going to be 60. Question number 26. 26 says, if 1 mile equals 1.6 kilometers, how many miles is 112.6 kilometers? So this is also proportion, and you have to know how to match your units. My units here are miles and kilometers. Now, if you were at Nolan Ryan last year and you did, obviously you would have had 6th grade math with the teachers here, we would have done a proportion box for solving proportions. We set them up with matching units, so miles and kilometers, ounces to gallons, inches, and minutes. We have to coordinate them. Top goes with the top, bottom goes with the bottom, and then the conversion factor would be 1 mile and 1.6 kilometers. So I mentioned 6th grade math because they set this up using the box method, which this is just a proportion. However, it's not written as 2 equal fractions. It is written as 2 equal fractions, but it doesn't have the fraction bar and the equal sign here. So I have 1 mile and I have 1.6 kilometers. That information is given to me. Then it's asking me how many miles matches 112.6 kilometers. So I don't know this value. I put a variable there and then 112.6 at the bottom. I'm going to do the same thing here that I've done for all of my other proportions, provided that I have done the practice in class and on homework. Cross multiply, then divide. 1 times 112.6 is just 112.6. Then divided by 1.6. In order to get your answer, you cannot divide with decimals down here in the numerator or in your divisor when you set up your long division problem. So I would move this over one place to the right, and whatever I do to the bottom, I must do to the top. Move this over one place to the right. This new problem is now 1,126 divided by 16. Then you should top in, bottom out that. Okay, you can solve that one on your own. Now, your percent change assignment is still an assignment. Just because I said skip it for now does not mean I want you to draw a big old fat X through it and not do it at all. No, you're still responsible for doing it, just not right away if you do not understand it. So for percent change, I have a formula over here that was given to you in class today. The percent change equals the amount of change divided by the original number times 100. So this is a big old fraction times 100 because percent is out of 100, and I'm going to end up with a decimal here, and I'm going to have to convert it to a percent by multiplying by 100, which is simply moving my decimal 2 places to the right. So, pardon my messy handwriting here, this is 60 decreased to 15. My amount of change is obviously going to be negative here, because it's starting at a large number and going down. However, I just want the absolute value of that amount. So that's why I put amount of change here. I don't put original minus the final number or the final minus the original. I just say how much has changed. So 60 minus 15 is going to go in my numerator, and my original number is the number that they always give me first. $60 minus 15 over 60. Original number, find the difference between the original and the new value. 60 minus 15 is 45 over 60. Now, if you want, you may go ahead and T-bow this out and you'll still get the correct answer, provided that you know how to divide 45 and 60. However, because I'm a math teacher and because I want you all to get more familiar with numeracy and identifying fractions that can be simplified, I'm going to want to make this more simple. And I want to find the largest factor to get it to the smallest fraction form so that my division problem is simple. 45 and 60 have 15 in common, so I'm going to simplify by 15. "45 divided by 15 is 3, 60 divided by 15 is 4. If you were to T-bow this out or look in your fraction, decimal, and percent assignment, or notes in your notebook, which should be in Unit 1, you will know that this is a benchmark fraction. This is something that we should know off the top of our head. 3/4, if you think about 3/4, that is 75 cents. 75 cents. Now I'm going to multiply by 100, which equals 75%. I'm literally moving the decimal 2 places to the right. This is my final answer. %75 decrease. So you could say negative 75%. So for this one, I need to set up my problem as 48 minus 12, because 48 is my biggest number and I want the absolute value of the change, over 12, my original number. 48 minus 12 is 36. 36 over 12. This too can be simplified to just 36 divided by 12, which is 3. I'm still not done. I have to multiply by 100. Then that gives me 300% increase. Done.